Aloha. We are going to today segue fully into bacteria and viruses. Today, we're actually going to do a quick simulation over how bacteria evolves over generations. What this activity is going to do is we have a population of strep throat bacteria. Okay, so these are not viruses, these are actual living bacterial cells. Okay, what we will do with these cells is we will look at our first population of cells, and this is all detailed in the instructions, but I'm just paraphrasing. What we're going to find out of these cells is they each have a number, and the number represents how strong they are. So if you have a number 1, you're pretty weak. But if you have a number 10, you're really strong. And if you're in between, you can figure out the scale. So if you're closer to 10, you're stronger. If you're closer to 1, you're weaker. Now, the next part is we're going to need 2 dice to represent the drug penicillin. The penicillin, for those of you who don't know, is just an antibiotic, okay? So it's medicine that helps you fight off a bacterial infection. If you don't have dice at home, I have left a link on Canvas that has a virtual die roller via Google. So I've done a split screen on the iPad, so we don't need dice to complete this. I can just use the computer. So you can do it however way you wish. But what I'm going to do is it's quite simple. I'm going to roll 2 dice, and if the sum of the 2 dice together is higher than the number in the cell, for example, let's look at this one, okay? So I need another dice, so what I'm going to do is I'm going to click on that blue 6 right there, and that's going to give me another dice, and now I have 2 dice. So I'm going to do a fresh roll, so I click roll, and those 2 dice will roll again. So my sum is 8. And let's say that I am targeting this cell. Because I have the same number as the number in the cell, I was not able to kill it. Because I rolled an 8, I can't kill it. To kill this cell, I have to get a 9 or a 10, okay? Or an 11 or a 12, anything bigger than that. But if you're that number or smaller, that means that that cell lives on, okay? So that's what we're doing for each cell. So let's do the rest of this round real quick. So I'm going to roll again, targeting the 6 underneath it. Same thing, okay, so I got a 6 again. Now I'm going to target this 5. Aha, I killed it. So I'm going to draw an X over that to show that I killed the cell, okay? Roll again. 6 and 3, so I killed off this 6, and roll again. And I killed off that because I rolled a 6 and there's a 3 in that cell. So notice that for all of those cells, I had to roll the dice each time, okay? So if I have 5 cells, I need to roll it 5 times. So what happens is I killed everything but an 8 and a 6, which conveniently is the same as this example. Funny how that worked. What happens next is for the next generation, only the survivors will reproduce. So through the 8 and the 6, reproducing, each cell is going to make a copy of itself. So the 8 is going to make another 8. The 6 is going to make another 6. And then I'm just going to go back to the 8 again. So I'm going to do a few more with you. So let's look at our first round. Your first round, okay, it's already numbered for you. Now, what you will have to do is just target each cell and do what we just did, okay? So what I recommend that you do is you go in columns, or columns, because they actually are straight. So what I mean is, like, I'm going to do this cell first, I'm going to do that one second, I'm going to do that one third, and then I'm going to tick off these, then I'm going to go down these. So if you do it in an organized pattern, you're not going to lose track of how many cells you've done, right? So let's go ahead and do a few of these. So I'm going to start with this 7. Did not kill it because I rolled a 6 and I need greater than a 7 to kill it. Rolled a 7, so I killed that 5. Next. And I rolled a 7, so that 10 survives. And then you just keep going down the rest of these, okay? So I'm just going to speed up here because I don't want to spend the whole video doing something that you guys can figure out quite easily on your own. Let's say I, for example, kill this one, that one, I kill this one. Okay, let's say I get done and I kill all those, all right? So what do I do next, okay? What do I do with all these blank ones? All you have to do is reproduce each of the surviving cells. So what I'm going to do is, to make this organized, I'm going to circle all the cells that I need to rewrite now. Okay? Those are all my survivors. So I'm going to go down here and I'm going to write those survivors in order, going down the same pattern. So I'm going to write 7, 10. Then I go to the next column. This is column 2. So there's a 9 there. So I write that 9. Now I go to column 3. There's a 6 there and a 5. So I'm just writing them in the order that I find them. 7. And then you have a 4 and then a 7. Okay, well now what? Just do the same order again. So go back to that first 7 and just rewrite them again. So it's 7, 10, 9, 6, 5, 7, and then 4, and then 7. And then start again. So 7, 10, 9, 6. And now I'm out of cells. And then you just do it over again, okay? So now I go down to this generation and I just roll the dice. So I roll the die. Did not kill the first 7. I did not kill the first 10. I did succeed in killing this 9, okay? And then what you're going to do is repeat that process. Now what you're going to notice over this time is that your average strength of bacteria is probably going to get stronger, okay? Which is why a bacterial infection is harder to fight, because as it evolves, the weaker cells are killed easily. And the stronger cells are then going to be passed on to somebody else through the infection spreading. And then when they reproduce, well, guess who's left? The strong ones. So then it means that if you take an antibiotic, you're going to get over the sickness, but by you taking an antibiotic, you're also going to kill all the weak cells, and the stronger ones are going to go to somebody else. So antibiotics are good for helping us fight infections, but they also step up the game of the bacteria and make it evolve quicker. And that means that it makes it harder for somebody else to fight the infection because they have to take a jacked up antibiotic to get over it. Okay, so go ahead and complete the simulation. There are 5 questions when you're done, and then submit to the link on Canvas. Have a great weekend.